Okay, so on this one, Jesse's bus ride to school is 5 minutes more than 2/3 of Robert's bus ride. Which graph shows the possible times of Jesse's and Robert's bus rides? So on this one, you notice that on all of your choices, Robert is on the x-axis and Jesse is on the y-axis. So that means if you could set up an equation where y equals something, that would look like y equals mx plus b, which is what you're used to. So if it says Jesse's ride to school is means equals. So Jesse's ride to school is 5 minutes more than 2/3 the time of Robert's bus ride. Well, Robert's bus ride would stand for x in every single one of these. So 2/3 of that x plus a 5 would give you the relationship between Jesse and Robert's bus ride. Now from there, you can just look at it and notice that 5 is the y-intercept. So that would eliminate A and that would eliminate D. So now you look at this and 2/3 is the slope, and it looks like that if you go up 2 from the y-intercept and over 3, you would hit a point. Here, if you go up 2 and over 3, you do not hit a point. So this is the answer. Now I want to throw something a little extra in here. You have to make sure that your units are going up by the same. So if it's 5, 10, 15, 20 on the x-axis, 5, 10, 15, 20 on the y-axis, then that means you can do the 2/3, like up 2 over 3. And this is the same thing, 5, 10, 15, etc., and 5, 10, 15, etc. So the 2/3 would work. And why I say that is because if you go over by different intervals, that could affect the slope and how that works. But that's how number 1 is worked out. All right, number 2. Which scenario could be modeled by the graph below? So the graph below, if you notice, has a y-intercept of 5 and it has a slope of, you have a clean ordered pair. It doesn't look like anywhere, possibly right there. Okay? But the y-intercept, you can say that it starts at 5. So this would be your y and this would be your x's. So if I was looking at this, I would look at my answer choices and kind of skim all the way down. And it looks like pounds of apples is your y every time. And then your x's is oranges. So this would be the pounds of apples. And this would be your pounds of oranges. So A says the number of pounds of apples, y, minus 2 times the number of pounds of oranges, x, is at most 5. So what you can do here is just write you a statement. The number of pounds y minus 2 times the number of pounds of oranges. So the number of pounds of y minus 2 times. So y minus 2 times the number of pounds of oranges is at most 5. That means it can only be 5. Or it can be less than 5. But it can't be greater than 5. So if 5 is its max, there you go. Okay? Less than means I can be smaller than that. So this right here is representing A, but I have to make sure it matches up here. So let's solve for that. Y. So if I solve for that y, I would add 2x. So that would be y is less than or equal to positive 2x plus 5, because I would add 2x. So does that graph as this? And the answer is no, because 5 would be here. This would be a positive 2, so that would be up to right 1. So it would cut like this. So that is not the right answer, so we can eliminate A. B says the number of pounds y minus half the pounds of oranges. So y minus half the pounds of oranges is at most 5. 5 is its maximum, so it has to be smaller than that, and it at most means it can equal 5. Now the same thing, you would add a half x, and you would get this inequality. The 5 matches, but the slope is 1/2, so you'd go up 1/2, and that's not the right answer either. All right, let's see. C says the number of pounds Y plus 2 times the number of pounds of oranges is at most 5. Then I would subtract that 2x to get this, and then we'll check that. It does start at 5. It goes down 2, right 1, down 2, right 1, down 2, right 1. So it's not an exact match, but that's probably going to work the best. It doesn't look like it crosses there, but that could just be part of the graphic being wrong. But just to be on the safe side, let's check D. Y plus half the number of oranges, x, is at most 5. So if I subtract that, I get negative 1/2 x plus 5. And if I start at 5 and I go down 1, right 2, I know that's not correct. So C is the right answer there. Okay, number 3, which is equivalent to t squared minus 36. There is a shortcut to this one. In class, I would probably have asked you to factor that, but you could go through this and multiply. If you multiply this out, t times t is t squared, t times -6 is -6t. Another -6t when you distribute, sorry, let's go through that again. T through both of them, and then -6 through both of them. So -6t and then positive 36. That's going to equal t squared minus 12t plus 36. Be careful that you don't mess up on your signs, that they're trying to trick you there. If you go through this one, you get t squared and then minus 6x when you take the t through. If you take this 6 through, you get 6t minus 36. -6t plus 6t would cross out, and t squared minus 36 is what you're trying to get. So B would be your answer there. The other way to do that would be to make 2 parentheses, and remember you have to multiply if there's not a variable on it. The 2 numbers here would multiply to be 36 with a negative on it. So one has to be a positive and one has to be a negative. With that logic, you could have eliminated this one and this one because the signs are not different. And the middle term goes away. There's no t term. So -6 and +6 would have been your answer. If you multiply this one out, you do get positive 36 on the end here. So that would be a way to eliminate that as well. This one would give you -36, but the middle, when you distribute it through, would not give you 0. It would give you negative 9t. Okay. All right, and number 4, which is the graph of the function of this? Now, one way you can do this is if it's a calculator active, you could just go ahead and go to the calculator, hit y equals, and then plug that in. 4x to the second minus 8x plus 7, and hit graph. And then you could compare them. There's some of them you can just throw out just by looking at that at a glance. It looks like you could eliminate definitely B and C. So these 2 are out. All right, looking at what you can do here, the first thing I would do is hit trace and try to find a number that works there. You can see that 0, 7 is an ordered pair. This is 0, 4, so this one's out. This has to be your answer. Remember how to find the vertex of these. If you wanted to verify the vertex, you could do second, trace, which is calc, go to minimum, Then go to the left side of the vertex and hit enter. And get to the right side of the vertex and hit enter. And then it will guess that for you. And the vertex is 1, 3. That's a guess, but you can see 1, 3 is the vertex. The vertex here is 1, 3 as well. So that's a reason why you could check the y-intercept to make sure that that works. What it's really doing there is, if you think about your parent function of y equals x squared, that 4 is stretching that vertically. So that's why that one's a little bit skinnier than this one. All right, number 5. The floor of a rectangular cage has 4 feet greater than its width, W. James will increase both dimensions of the floor by 2 feet. Which equation represents the new area? So anytime you see something like this, you need to draw a rectangle. So that rectangle would look something like that. And let's read it again. The floor of the rectangular cage has a length 4 feet greater than its width, W. So the width of that cage is W. The length of it is 4 feet more than that. James will increase both dimensions of the floor by 2 feet. So the W would get 2 added to it, and the W plus 4 would get 2 added to it. What equation represents the new area? Area equals length times width. So the new area after this 2 is added, the length would be W plus 6, and the width would be W plus 2. Now you can multiply those out. Take the W through, take the 6 through, and simplify. That would be W squared plus 8W plus 12, which is D. Draw your diagram. All right, number 6. Sean and Curtis went for a walk. Sean began walking 20 seconds earlier than Curtis. Sean walked at a speed of 5 feet per second. Curtis walked at a speed of 6 feet per second. For how many seconds had Sean been walking at the moment when the two boys had exactly the same distance? So let's think about this. Distance would equal however fast you're going times however long you walked. Okay, so Sean began walking 20 seconds earlier than Curtis. So we know that Sean got a head start. Okay, so what we're going to do is we're going to write T equals the time that the boy walked. How long has the boy been walking? D is the distance traveled, and R is the rate. So Sean began walking 20 seconds earlier than Curtis. So let's start with Sean. So Sean would be D equals RT, and Sean would be walking at a rate of 5 feet per second. What we're looking for is the moment when the two boys walk the same distance. So we don't really know the time and we don't know the distance yet. That's one of those stay as variables. Now, what about Curtis? So his would also be D equals RT. Now, here you have to think, well, if Sean has walked 1 second, he has traveled 5 feet. If he walks 2 seconds, he's traveled 10 feet. So if I put that in there, 1 and 2, I would get 5 and 10. Curtis started walking 20 seconds after him. So even though his rate is 6, what would his time be that he is walking? So let's say the clock started here. But what would we have to do to his time to see how long he's been walking? What if we took T minus 20? So what does that mean? Well, if the clock has been going for 30 seconds, so if the clock started and 30 seconds had passed, how long does that mean that Curtis had been walking? And the answer to that would be 10 seconds because he started 20 seconds later. Okay. All right, now, what does that mean? So to solve when they would have walked the same distance at the time, you could set Sean's distance equal to Curtis's distance. And then just do the math there. So distribute the 6. Don't forget to distribute. And then I would subtract 6t to get negative t equals negative 20 or 120. And then divide by negative 1 into everything to make the t a positive number. So when would they have walked the same distance? And that would be at 120 seconds. To verify that, let's say that Sean has walked 120 seconds. What would his distance be? Well, 5 times 120 equals 600 feet. And Curtis, if the timer had been going off 120 seconds, then that means that he had been walking 100 seconds, and at 100 seconds he would be 600 feet. So that's how you determine when they would be walking this where they would be at in the race at the same time. They would both be at 600 feet at 120 seconds into the race. All right. Number 7, the math club sells candy bars and drinks during the football game. 60 candy bars and 100 drinks will sell for $2.65. 120 candy bars and 90 drinks will sell for $2.70. How much does each candy bar sell for? So what you don't know in this problem, you don't know the price of candy bars, and you don't know the price of drinks. But you do know if you purchase 60 candy bars and multiply that by the price and you add to it 110 drinks, you will have $265. If you have 120 candy bars plus 90 drinks, you have $270. So you have to solve for X because that's the price of the candy bar. So if you recall, there was something called elimination when you have 2 unknown variables in 2 equations. Elimination would be easier here because they're stacked x's on x's and y's on y's. You got to get these numbers to be the same but opposite signs. It's easier to make these x's go away because if I multiply 60 by negative 2, I'm going to get negative 120. But if I do that one, I have to do this one as well. So negative 220. And then 265, just don't want to mess that up. 265, double that would be 530, so negative 530. So you've changed this one into the one down here. Now, if you recall, you add these. So if I add these, I have 90 minus 220, or plus a negative 220, which is essentially 90 minus 220. Which is negative 130y, and then 270 plus a negative 530. You get negative 260. When you divide that by negative 130, you get 2. So what did Y stand for? Oh, sorry. Y was the price of a drink. So it wants the price of the candy bar. So what you have to do is take this and plug it back into an equation for Y and solve for X. So this would be 220, 265, and 60 there. I would subtract 220 from 265, and that would leave me with 45. And then you would do 45 divided by 60, to get 75 cents. And that's it. All right, number 7. What is the smallest of 3 consecutive positive integers if the product of the smaller 2 integers is 5 less than 5 times the largest? So the first thing you have to understand is consecutive, and that means one after the other. So if I had one, x is the smallest, the next number, sorry, computer's messing up there. Okay, so if x is the smallest, the next number would be x plus 1 would be the middle one, and x plus 2 would be the largest number. So it says, if the product of the smaller 2, so the smaller 2 is x and x plus 1, product means multiply, is 5 less than 5 times the largest. The largest is x plus 2, so 5 times the largest, and then is 5 less than that means I would subtract 5. Now we have to find the smallest. What is the smallest? We're solving for x. So the first thing you need to do is distribute. And simplify. X squared and x will not go together. Over here the 10 and 5 will, so I have 5x plus 5. Now, you have too many x terms. You have an x squared and an x. Now, this x could go subtract 5x. Sorry about that. So that would give you negative 4x. Now, remember what I taught you. If you have an x squared and an x, that means that you have to put them both on the same side and bring the other number over and set it equal to 0, because there's no way to solve for those unless you do that. Now, you factor. So you do parentheses, parentheses, x, x. What multiplies to be negative 5 is 5 and 1. But when I put them together with this one and this one, I have to get a negative 4. So this would be negative 5 and positive 1. So what's the smallest? Well, now you have to solve. So you do x plus 1 equals 0, x minus 5 equals 0, and now solve. So you subtract 1 and get x equals negative 1. You add 5 and you get x equals 5. What is the smallest of 3 consecutive positive integers? So there's another keyword. The answer has to be positive if the product of the smaller 2 integers is 5 less than 5 times the largest. So what is the smallest? It has to be positive, so that means this one goes away. 5 would be your answer. If it asks for the largest, you would just have to do 5 plus 2 to get 7. All right. This function models the approximate height of the object t seconds after it's launched. How many seconds does it take the object to hit the ground? So if you think about this, this is going to be the height of the object, and t is the time. So I'm looking for when that hits the ground. So what I want to know is when my height is 0. Now we just did a problem like this. What do you do if you have it set equal to 0 and two things that can't go together? You factor. Remember, if the front one's negative, you probably want to pull that out. And you probably should notice that 5, 20, and 60 are all divisible by 5. So if I divide a 5 out of this, I get t squared. And this would leave me with negative 4t. And that would leave me with negative 15. Same thing as the last problem. Now try to factor that. So you'd have t and t. Okay, and what multiplies to be negative 15 is 5 and 3. And that's about it. Oh. So this is something we've been doing. Now pull that negative 5 out. you'd get t squared, and that would be -4. And 5 into that would be 12. Oh, -12. All of those change signs because if you pull a negative out, it changes the sign. So if I distribute that through, I would get this up here. So now try to factor again. What multiplies to be -12, but then would give me -4 when I added it. And that would be -6 and +2. Now solve. Remember, set each factor equal to 0. Zero equals -5 does not have a variable, so it goes away. If I add 6 to this, I get t equals 6, and if I subtract 2, I get -2. So after how many seconds does the object take to hit the ground? Does it make sense to have negative seconds? No. Time is 6 seconds, and that would be the logical answer. You could also graph this in the calculator. As long as you understood that the x-intercepts are what you're looking for. Think about this, the t's here, the x values would be negative, so it doesn't make sense to have negative time, but you're looking for that value. You could hit trace and kind of guess at it. 1, 2, 3, 4, 5. It looks like it is at 6, so if you hit trace 6 enter, you get 0, which is 0 hot, so that would make sense. 6 is the answer. Alright, 2 times Antonio's age plus 3 times Sarah's age equals 34. Sarah's age is also 5 times Antonio's age. So just say age. How old is Sarah? Alright, so you've got 2 ages. A is Antonio's age, and S is Sarah's age. Two times Antonio's would look like this. 2 times Antonio plus 3 times Sarah's is 34. Sarah's age is, so that means S equals 5 times Antonio's. Then you're trying to find out how old Sarah is. So now, again, you've got 2 equations with 2 different unknowns, A and S. If you notice, S equals 5A, so this one we can use substitution. So 2A plus 3, and S is 5A, equals 34. So 2A plus 15A equals 34. 17A equals 34. And A equals 2. So that means Antonio is 2 years old. How do I find Sarah's? I find Sarah's by putting 2 back in for A. So Sarah is 10. 2 times Antonio's age plus 3 times Sarah's is 34. So 2 times 2 plus 3 times 10 is 34. And Sarah's age is 5 times Antonio's. So Antonio's 2, Sarah's 10. So the answer is 10.